Did you get it right? Yes. You did get it right. Yeah, you. Victor. What'd you get? Tell me how you did it. Shh. Yeah, we got side squared times the square root of 3 all divided by 4. So I said 2 square root of 7 squared times the square root of 3 all divided by 4. Then what'd you get? You did a great job. Yeah, that would be 4 times 7. Nicely done. Times the square root of 3 all divided by 4. Now, if and only if you're multiplying 4 times 7 times the square root of 3, you're allowed to cancel those 4's, which is 7 square root of 3, which is about 12.1 units squared. And you got it right, Victor. Nice job. So that's review. If you have not watched the lesson or read the book or talked to a friend or talked to me, you're not doing your job. So please do those things, all right? Okay, new stuff. Here we go. We're gonna move on and find the area. It was 12.1 units squared. We're gonna learn how to find the area of any regular polygon, not just equilateral polygons, or like. Yeah. Okay, thank you so much. Okay, this is let's go this one. Yeah, there we go. There we go. Okay. All right, what type of a figure is inscribed in my circle here? Yeah, it's a regular polygon. What type, though? It's a hexagon. It has 6 sides, okay? All right, we're going to learn how to find the area of a hexagon. The first thing we're going to do is we're going to draw in the center of our hexagon. Oh, you do? Oh, yeah, mine doesn't. So what we do is make one triangle out of our hexagon here. And you'll notice, right, that I have quite a few hexagons in here, right? In fact, how many do I have total? Right? I have like 1, 2, 3, 4, 5. I have 6, right? Okay. All right, we're going to introduce a new term here. Okay. And the term we're going to introduce is something that's called the apothegm. It's a strange word. The apothegm is going to be labeled A. And this is how you spell it. A-P-O-T-H-E-M. It's apothegm. The apothegm is going to play an important role in finding the area of any regular polygon. The apothegm is our distance from the center perpendicular to a side. That's going to be our apothegm. We're going to call it A. It's going to be our apothegm. So if I was just looking at this one little triangle here, this one that I have highlighted, okay, apothegm. The distance from the center perpendicular to a side. Distance from the center perpendicular to a side. So we know that the area of any triangle is 1/2 the base times the height. Okay, so the area of that triangle I have in yellow would be 1/2 the base times A, where A is the apothegm, right? Because the height is the apothegm. So if I consider this part down here, if I consider that one side of my whole entire figure of my hexagon, right? How many of these do I have here? Yeah, right, all the way around, right? What would you call the distance all the way around? There's a word for it in geometry. What's it called? Perimeter. Very good. Yeah, it's called the perimeter, right? So if the base times the apothegm times 1/2 is one of the triangles is the area, then how can I extend that to the entire thing? Multiply it by 6, right? So what we're going to do is we're going to say this. We're going to let B equal the perimeter of the regular hexagon. If I have a perimeter, then the entire area can be defined as 1/2 the apothegm multiplied by the perimeter. This is brand new. 1/2 the apothegm multiplied by the perimeter will give you the area for any regular polygon, no matter the shape. Okay? Any regular polygon, no matter the shape, we're going to put that on our toolkit. And it looks like this. Okay, so let's head back over to our notes, and we have a regular polygon. And it looks like this. And our goal here is to find the area of a regular 12gon. Okay? We have to know some information about it, so let's put some information on the drawing. So the center line, and let's make a little triangle out of this. I don't think yours doesn't have this on there, right? Okay, so we're gonna make a triangle out of it. Have it look like this. And since it's a regular figure, we know I'm gonna tell you that one of the 12 sides is 4 units, and this is 9 units. Okay. All right. Do we know what the apothem is yet? No, we're gonna get it. Okay. Our whole goal is to find the area. So here's what we have. The area is equal to 1/2 the apothem multiplied by the perimeter. Is there something that we do have, though, or could find? Yeah, very good. Jared, how would I get it?
4 times 12.
He says it's 4 times 12. 4 times 12, because each side is 4 length. There are 12 total sides. So that gives me a distance of 48. Is that correct? Yep. Okay, so I've got a perimeter of 48. Good, I have half the stuff that I need. All right. So what I'm going to do now is I'm going to take this, I'm going to draw in my triangle. That was really strange. So I'm going to draw in, here's my A for the apothem. And I'm going to make a larger drawing right outside of this picture here, okay? So this is 9, this is A, the apothem. What is this side then? It's the base, but it's what? It's 2, yeah, because it's exactly halfway, right? So this is 2. So how do I get A? I could use the Pythagorean theorem, right? I could say this. 2 squared plus A squared is equal to 9 squared. Okay, always remember that the side that's opposite the right angle is the hypotenuse. So that means that A squared has to be 9 squared minus 2 squared. So A squared must be 81, take away 4. So A must be the square root of, what's 81 take away 4? 77. So please, on your calculators, find out the square root of 77. 77 square rooted. Can someone help me out and verify what you get? 8.7. All right, let's rather one decimal place, so that'd be what, 8.8. Okay, thank you so much. 8.8. So 8.8. So there's my apothem. Okay, do I have my apothem? Do I have my perimeter? All right, so if I plug back in, I should be able to easily find the area of this thing. So the area has to be 1/2 the apothem, which is 8.8, times the perimeter, which is 48. You don't have to do that by hand. You can plug that straight into your calculator, okay? So I'm going to take 1/2, which is 0.5, multiply it by 8.8, and then multiply it by 48, and what did you guys come up with? 10.6. Ooh, did I do something wrong? Can someone else verify that I got this? Okay. So I always say about 211. About 211 units squared. And then the book is going to give you an about answer, so an estimate. So if you're within 0.1, you're probably okay. All right. All right, what do you think? Was that easy, medium, or hard for that one? Okay, we're going to have to use some trig on the next one, all right? So here's some trig over here. I think this is what we use the trig on. Yep, we definitely use some trig on this one. Okay, is this what you guys have? Did you picture? All right, so we're asked to do 2 things. We're asked to find the perimeter and the area. We have to find 2 things here, perimeter and area. All right, so what do we know so far? Name one thing that we know. The apothem is what? 8 units. And what else do we know? We have a right angle. What else do we know? There's 5 sides. So that makes it a what? A pentagon. And is it a regular pentagon? Yes, because it says so right up here. All right, good. So here is the trick about going about doing this. What you want to do is you want to create a central angle triangle. So here's what I mean. So from the center to a vertex. From the center to a vertex. You want to create a central angle here. There is a central angle. That's an idea from yesterday. central angle. Okay, what is my central angle worth, and how do I know? How'd you get 72? You're totally right. What'd you do? Yeah, you're right on top of it. So take 360 degrees, divide by the number of sides. A pentagon has 5 sides. That means I have a 72-degree central angle. Everybody on board? All right, good. So this is 72 degrees. Now what I'm going to do is I'm going to draw one of these triangles over here. So it's going to look like this. Okay, I know that this is 8. I know that this angle now becomes what, you guys? Half of 72, which is 36. Very good. This is a right angle, and the thing that I'm looking for is over here, which is called x. Okay, now, before we move on, we should remind ourselves of some trig. The sine is defined to be what over what? Opposite over hypotenuse. Good. What's the cosine defined to be? Adjacent over hypotenuse. What's the tangent defined to be? Opposite over adjacent. Very good. Okay. Which angle do I know for sure that's not the right angle? Well, no, I have the 36 angle, right? I have this one here. So what is this side compared to the 36-degree angle? That's the opposite side. Agreed? What is this side? The adjacent. Which one deals with opposite over adjacent? Tangent. So I need to say the tangent of 36 degrees is equal to x over 8. Everyone see where I came up with that? You got to use a little bit of trig sometimes in these. So the tangent of 36 is x over 8. My goal is to solve for x on this, so I'm going to multiply both sides by 8. Cross out. Multiply by 8. So x equals 8 times the tangent of 36 degrees. So we need a calculator for that. All right, let's do 36. Let's do tangent. 36 tangent. That gives me that multiplied by 8. I got 5.8. Can someone else verify that? 2, 3 people? Okay, so I got 5.8. So x is about 5.8. So if x is 5.8, question is, what's the entire length of one side? Hey, we just double it, right? He says 11.6. So if that's 11.6, then what is this? And then what is this? And how about that? And how about that? So how many 11.6s do I have? I have 5 of them, right? So the perimeter is equal to 5 times 11.6. So the perimeter is, someone do that for me. What'd you get? 58? Exactly? All right, so the perimeter is 58, and now I need the area. So the perimeter I got, now I need the area. Area is 1/2 the apothem times the perimeter. So the area must be 1/2 the apothem is 8. The perimeter is 58. So the area must be, what's 8 times 58 all divided by 2? Let's do that. 8 times 58 equals all divided by 2, 232. 232 units. All right. Okay, here we go. Is that right? Okay. All right. For this one, we only have to find area. So we don't have to find the perimeter. We only have to find the area. Okay, so we have a square inside of a circle. We know a few things about it, right? We'll start off by writing this down. Area equals 1/2 the apothem times the perimeter. So 1/2. What is the apothem? 2 square root of 2. Good. And then all we need is what, you guys? The perimeter. All right, good. Okay, so let's draw this triangle out over here. Here's what I have. I know that this is a right angle. I know this is 2 square root of 2, and I know this is 4. Do I know what angle this is? This little one up here? Yeah, it's 45. How do you know for sure it's 45, though? Yes, there you go. So that is 2 rad 2. You are totally correct. For those of you who did not catch what we just talked about real quick there, I have a 4-sided figure, correct? I have a square. So this central angle would have to be 360 degrees divided by 4 which is 90 degrees. And that totally looks like 90 degrees, doesn't it? So then half of 90 degrees gives me my 45-degree angle. Okay? So I definitely have 45 there. I got 45 degrees there. So if half of this distance is 2 rad 2, what's the entire distance? 4 rad 2, right? Okay, did we forget how to add those things together? If this is 2 rad 2 and this is 2 rad 2, the total distance is 4 rad 2. Okay, you add the parts out in front. As long as the square roots are the same, you can do that. So the perimeter then, is 1/2. 2 rad 2. The perimeter is 4 times 4 rad 2. So we got 1/2 times 2 rad 2 times 16 rad 2. All we have to do now is clean this piece up. No problem. Alright, so we're going to have 1/2 times, let's see here. What is 2 times 16? 32. Good. What is the square root of 2 times the square root of 2? 2. So 16 times 2. Oh, wait. And then the 2's cancel out, don't I? So what's my area? 32 units squared.